can you solve this geometry challenge? Here's the question. Let's have a circle, and now let's draw chord AB. Now point P is outside of the circle. Now let's draw tangent segment PA and PB, wherein A and B are the point of tangency. And then let's draw secant PS. Now let's call this point as point Q and this point as point R. Now QR is given, which is 2 units, and RS is 3 units. Now the goal in this question is to find the length of this segment PQ, and let's represent this as X. Now the question is, what is the value of this segment X? Now pause this video right now and see if you can answer this question, because I will show you the answer and the solution in 3, 2, 1. The answer to this question simply equal to 10 units. By the way, this figure is not drawn to scale. So the question is, how do we get this answer, and what is the solution to find the answer? I will show you 2 different approaches to answer this question. So let's start with the first one. But before we begin, take note that don't assume in geometry, in solving geometry problem, don't assume if it's not stated. So we can't assume that this QS is a diameter, because this secant PS can be drawn in this position, but can be in any position in this circle like this. So in order to solve this, what we're going to do is to solve this in general position of this secant PS. So let's begin in this position. So now, how do we find the value of X? So what we're going to do is to draw what we call another secant that pass through the center of the circle. Now, we are sure that this secant contains the diameter of this circle. And since it is a diameter, this is automatically perpendicular to this chord AB, or it bisects chord AB. From here, let's have this intersection as point C. And here's what we know for sure in this figure. First, since PA and PB are the tangent segments, so we can say that PA equals PB. Another is C is the midpoint of AB. In short, AC equals BC. Alright? Or AC equals CR plus RB. We will use this information to answer this question. So let's begin. First, we will use what we call the chord-chord power theorem, or it is also known as the power of a point. If we have 2 chords intersect inside the circle, of course, we can multiply both parts of the chords together and then set them equal in our figure like this. We can say that segment WY times YN equals IY times YD. So using this concept to our given, we can say that RB, this is RB, multiplied by this segment, AC plus CR, this equals to 2 times 3. Also take note that AC equals CB plus RB. So we can replace this AC with CR plus RB. So this becomes RB multiplied by 2 times CR plus RB equals 6. Now let's set aside this result. Now, another theorem that we can use in this given is what we call the secant tangent product theorem. If we have a tangent segment and a secant segment, we can use this theorem. So we have the secant segment times the external part of the second segment equals the tangent segment raised to the power of 2. On our given, we have tangent segment PB and secant PS. So we can use the secant tangent product theorem. So we have PB squared equals the whole secant x plus 2 plus 3 times the external part of the second segment, which is x. Simplify, this becomes x multiplied by x plus 5. And now let's set aside this result. Now from here, we will use what we call the Pythagorean theorem using this right triangle. So using the Pythagorean theorem, we get that PB squared equals PC plus CR plus RB raised to the power of 2. Now, from here, also take note that we have this small right triangle right over here. And using Pythagorean theorem again, we get that x plus 2 raised to the power of 2, or the hypotenuse squared, equals to PC squared plus CR raised to the power of 2. Now, getting the value of PC, we get that PC squared equals x plus 2 squared minus CR raised to the power of 2. And we can replace this PC squared with this value. And there you have it. Now, simplify CR plus RB raised to the power of 2. This will give us this expression. And why we do that? Because we can now eliminate negative CR squared and positive CR squared. And also, we can factor out RB in these two expressions. So we have RB multiplied by 2CR plus RB. And this is familiar to us because it is given that equals to 6. So using the chord-chord power theorem. So we can replace this with 6. Now, from here, notice that we have two equations that are equal to PB squared. In short, we can say that x plus 2 squared plus 6 is also equal to x times x plus 5. And from here, we can now solve for the value of x. Simplify x plus 2 squared. This is x squared plus 4x plus 4. And multiply x to x plus 5. We have x squared plus 5x. Subtract x squared on both sides. So these are 0. So we have 4x plus 4 plus 6 equals 5x. Subtract 4x on both sides and add 4 and 6. We get that x equals 10. And that is our answer to this question. So this is our first method to answer this question. And another way to answer this kind of question is by using what we call the invariance principle in geometry. Here's the full definition of the invariance principle in geometry. So this principle states that when a property remains unchanged under different configurations or transformations, you can solve the problem using any convenient case, often a symmetric one, because the result will be the same for all valid configuration. So what we're going to do is to choose one unique case that we can solve the value of x easily. And of course, that case is when QS is the diameter of the circle. So if QS is diameter, this is very easy to solve. Because, again, using the chord-chord power theorem, we can say that AR times RB equals 2 times 3. Or simply, RB squared, since they are equal, RB squared equals to 6. Now, another thing, we can use also the second tangent product theorem again, and using tangent segment PB and secant PS. So this will give us PB squared equals x multiplied by x plus 2 plus 3. This simplifies to x times x plus 5. Now, again, using Pythagorean theorem in this right triangle, we can say that PB squared equals r plus 2 squared plus RB squared. And now we know RB squared is 6. So we can replace this RB squared with 6. Now, again, we have two equations in terms of PB squared. And again, we can equate these two results. And there you have it. Since this is the same thing as before, we get the value of x equals 10. And this is our second solution for this question. Therefore, given this figure, then the value of x simply equal to 10 units. And as always, we are done.